Okay, so now in the previous lecture we have seen what is no tension condition, and we have developed or we have derived one equation, that is eccentricity should be less than or equal to z by a, where z is the section modulus and a is the area of cross section. Now for rectangular section we will be deriving what are the limits of eccentricity, what is the e value. So for rectangular section, first we'll write the main condition, e should be less than or equal to z by a, where z is the section modulus. Let's give the dimensions here. This dimension is b, the width and the thickness is d. Now we'll first find out ex. So ex should be less than or equal to zx by a. Similarly ey will be less than or equal to zy by a. Substituting the values of zx, what is the value of zx for rectangle? It is bd square by 6. Area is b into d. Here it will be db square by 6 divided by bd. This b will get cancelled, d and d square will get cancelled, so ex should be equal to d by 6. Similarly ey should be less than or equal to b by 6. So these are the range of eccentricity for rectangular section. Now what is the maximum value of ex that is possible? D by 6. Maximum value of ey is b by 6. Now we will plot this all points here from the centroid. So this is the centroid. This distance here, this distance is ey distance, ey. Similarly this distance is also ey. Now on the y-axis the distance is ex, and this is also ex. Now if we connect this all 4 points by a straight line, then we'll get an inner portion here. We'll just shade this. Now after shading, what we have to do here, we have to give the dimensions for this. So let's give the dimensions here. This distance, what is this distance, ex or ey? This is ex. Similarly this distance is also ex. Now what is the maximum value of ex? D by 6. So this is d by 6 and this is d by 6. Now if we add this d by 6 and d by 6, we will get the total value as d by 3. Similarly, when we will be seeing about y-axis, then this distance is ey. Similarly this is also ey. What is the maximum value of ey? B by 6. This is also b by 6. So if we add this b by 6 and b by 6, the total value we'll get is b by 3. So now if you see the middle third area, okay, of the total rectangle, the middle third area is a shaded portion, and this shaded portion, this is called as the core of section. Core of section, that means a core of rectangular section. Now what is the speciality of this core? If any load is present within this shaded area, if any load is present in this middle third area, then there will be no tension which will be developed. Okay, if the load is present in this area, that means the location of load is here, or let's say here, then there will be no tension that will be developed in the member. But if it is outside of this core, then there will be tension that will be developing. So we'll write here, for no tension, load must lie within, the middle third shaded area, the middle third shaded area. This central shaded area is called as this central shaded area is called as core of section, or sometimes it is also called as kern of section. So both things are same. Okay, so here you have to do this derivation, you have to practice this derivation. Also you have to remember this one point, that if the load is present in this core, then no tension is developed. And another important, or I can say the most important point from here is, you have to draw this core. Okay, so there can be a question, in fact there are few questions which are asked in the previous years, that draw the core for rectangular section with width 100 mm and depth 50 mm. Okay, so for such width and depth given, you have to draw this core. So I have given it here now, the value of ex ey, how to calculate it, and then draw the core.